afternoon, dear colleagues. I'd like to congratulate all of you on our holiday. Speaking more about AI and building on this topic, I would like to present my slides. I am Alexander Tokarev. I work on AI development in combination with TRIZ tools. And also I am a professional of TRIZ. We will keep talking on LLMs based on these approaches. LLMs should be instrumental in reducing our time we spend for addressing a problem. Of course, we know that TRIZ tools are very much powerful, but they are very labor intensive. And we see that some of the work can be delegated, can be sent for AI. I am not referring to AI per se, but again, we here are speaking of LLMs, of large language models. Now, we had the idea of drafting a system that could be instrumental for a person using TRIZ in their work with our tools. We wanted to automate working with tools, and on the other hand, we wanted to address ideas that could be instrumental for that, and then further used to address tasks. Large language models, you know much about these language models. We have been hearing very much about ChatGPT, DeepSeek, and our own Russian domestic developments, so I don't want to speak a lot about them here, but I'd like to underline that it's not intellect in itself. This is a machine which forecasts the probability of our next words. There is no meaning or sense for these machines. Sense or meaning is always and only available to people. And for addressing problems, we have a user, we have TRIZ algorithm for analysis and idea generation. We have a user, and we can have a bank of corporate solutions, which is here, like what Tatiana has mentioned in the previous input. We can generate the number of solutions beforehand in advance and use ready-made solutions. And we also have the large language model, which can address the corporate knowledge base at the same time. Or it can work with something else. It can work with the wide web or the internet. We know these technologies, they are very much widespread, so technically it is implementable, and we can do that, we can use these technologies. Now we have prepared this roadmap for working with the model itself. We have suggested moving the models across along a particular route, and we set the task to automate this process with workflow without the human intervention or interaction. We have the situation description to the left, and then after that, the model works with the situation based on a predefined algorithm. What we have already tested. We have tested problem description, a list of elements it finds there. These are our resources. We will be working with the resources. Going forward, it defines requirements, what a person wants to achieve based on the task set. This model can enhance his or her requirements with its own standard requirements as it believes, and this is added to the list of these requirements. Also, this is related to those elements which are used, while the problem itself, this is formulated by a person. This LLM generates its own ideas. There are quite well correlating or can be generated, all those directions can be generated quite wonderfully in this wide scope. Looking at social sites, so it can speak of some social solutions about a person, about hardware, and all that. So it is really possible. This is what we have as an analytical stage, and then after that, the next stage is solution generation. LLM generates information, and then it keeps working with this information. We have seen some tested approaches, FOS. These were not FOS per se. They were like the ways how we searched for similarities or equivalence online. It can use the resources it identified at the analysis stage. It can formulate IFRs. It can work with inventive principles. And I have already delivered a presentation at a previous conference. We can enhance this list of modules that can be used, also connected, related to almost all TRIZ tools. Because actually for us it's not quite important what to use. We split the problem, but for us it does not really matter how a problem is solved, using trees or without them, just along. So we can add those tools, and if this process and workflow is enhanced, everyone will be happy. So again, these are the solvers, and then after that solvers, we have a list of ideas or a set of ideas. Looking at this idea set, a person can make a choice on which ideas to use. Then after that, after generating ideas, we ask the model to find a possible and look at possible consequences, what could be the secondary problems. And this is how we reach contradictions. The contradictions are those secondary problems that might appear after we generate our good ideas. And after generating those secondary problems, we can move them here to the analysis stage, and it will work with this information, with these secondary issues, secondary problems, which is, of course, quite important for that. And this is what I mean. This is what we have as the undermining of contradiction.
So some requirements are failing. So we cannot see actually the block of contradictions. It is covered by techniques, but it is there and it can formulate all contradictions and everything. So as the result of all listed tools were tested, and LLM works with it pretty well. Component analysis of the system is made, identified of problems, define a list of solutions, then listing probable causes of undesirable effect. It's also implementable. It is made, but you can harness it so that it won't be too loose. Then identifying secondary problems, formulating technical contradictions, it works properly. And even working with other tools, it works pretty well, but we cannot teach it with functions. It doesn't know yet, but it's a matter of time. We will teach it. So let's have a look at short example from real production practice. So we have this transporter with the rubber band. So it's pretty dirtified with the product, which is transported by this line. So, and in the bottom of it, you are putting cleaning knife as this plate, metal plate. And this very knife, if it's not pretty broad, so by the edges of this band, there are some dirtified portions. So there is a genius idea. You can expand the knife itself. But if this knife will meet some breakdowns of the band, so then it will break the whole transporter. So what was put into this machine? This very text: to reduce product spillage from the conveyor belt, the size of the belt cleaning knife needs to be increased. This will cause the knife to tear the edges of the belt. That's it. What was put, what was downloaded in the machine is the example. And as LLM, we use DeepSeek chat. At first, they had version 3, and then 3.5. Talking about which LLM was used, and we used also ChatGPT, and then some AI which is downloaded to our local computer. So it's similar, but you have to select necessary prompts for it, and it will handle the task. And now the information from all sources is like that. That local model is pretty trained well. So what LLM does, this very prompt, which is intended to work with it, Sounds like that. So from general phrases, we go down to the very basics of operation of work with LLM. So you are actually a specialist in linguistic tree systems thinking. Element. So then we explain what does it mean? Element is physical material element or components which may be changed and used for problem solving. And from the other hand, problems, troubles, harmful processes, characteristics are not resources. And then in the user section, there will be a text, extract the words of the groups of the words from the text, then denote element. So you can call it component. Give the answer in the form of a list, only resources, in a nominative case in Russian. So we formulate our request, how to do it correctly. So we give the role, we describe the situation, and then we write down what do we expect from it. Do not write anything else. Don't write any introductory phrases or explanation. Just write the list of resources only. Use only the following text. Do not add information from yourself. And then we put the text itself, which was there in the very beginning. So here you can see some historical notes. Don't write any additional phrases. So these are techniques of prompts, adjustments of prompts to some particular element. DeepSeek chat, we talk about that. It's not thinking DeepSeek, it's only chat. It's pretty, it has its own character, and it, like a chatterbox, gives a lot out. So you don't have some additional unnecessary information. You have to get only necessary resources. So what LM gave you that the following elements were detected in the situation: conveyor belts, knife, project, and edge. Edge was perceived as a standalone element, but it's a part of belt, but it was selected by the machine like edge. But on the other hand, we can work with it. So component analysis is made pretty easy. And so then you go into situation of user, so I hope you have your presentation and you will learn this text pretty attentively. From the text of situation, you have to get an fulfilled requirements. Then identify keyword phrases that may indicate problems for each problem. Determine which requirements is not satisfied. So out of that list, we get problem and description at the same time. The problem is unsatisfied request. So requirements. So for LM, it should be convenient, and it does pretty well. So what kind of requirements were identified? Increase the size of the belt cleaning knife, prevent belt edge tearing. So it's pretty smart and reasonable approach. The requirements were only two. However, the situation was made out of two questions. Then separate prompt for problems. Anyways, then formulate each problem separately and give the answer as a list of problems in nominative case in Russian. Do not write anything else which is not needed. So, summary of problems. It was seen only one problem. Increasing the knife size can cause the edges of the conveyor. And then automatically it comes down to the next stage. So everything what we can see is automatic regime. So the person put only 2 or 3 sentences. That's it. So you are excellent tree special and you can generate ideas. And please pay attention that roles are different in any case. In some cases, roles are not used by trees at all. In the user section, the problem, the list of resources, situation will be described. So it uses that situation, that information which was dragged out before. Both resources and problems and requirements are accessible to it. So we formulated roadmap, then suggest that act consistently, consecutively, take the first resource from the list and generate the idea of how to modify it to solve. So out of the pretty simple situation, you could see 8 ideas. So, for example, using knife with rounded edges, use a knife with adjustable belt pressure, installing additional belt support rollers, then variability geometry, vibration system to clean the belt, you know, protective screens. So we even haven't used trees, and it was figured out by the machine. So we can use it as the initial generator of idea. Then resource. So take some particular resource and do something with it. So use some protective pads. Of course, part of solutions will be repetitive and use a belt with reinforced edges. It was not back then. Before, design a knife with adjustable length. It was something with it. Then it's position the product to minimize pressure on the belt edges. Then even install sensors to monitor the condition of the belt edge. So pretty easily it could go to subsystem and even developing instructions for personnel how to behave correctly. And then secondary problem. You are excellent linguistics specialist, so TRIZ is not involved. In user section, there will be a list of ideas in the user section, which are generated. So it's necessary to determine the consequences of the proposal. Ideas follow sequentially. Take an idea from the list of ideas and assume all possible problems when implementing this idea. So here I give you only beginning because this list consists of 19 elements. So then we will spend a lot of time on it. For example, idea, increasing the knife of the belt cleaning knife. And then the result of it will increase the knife weight, pretty fair, and the cost. And increase the risk of belt damage due to the increased pressure. So we cannot understand what is the proportion of pressure and the weight or the size of knife. So actually, if you ask it, it will give the explanation. Well, maybe it will formulate the answer. It's understandable for me, kind of. Using a knife with rounded edges will reduce cleaning efficiency due to less contact with this belt. Pretty okay. Then using a knife with adjustable belt pressure will increase the design complexity and system cost. So we didn't use all the power of trees yet. No? And so as the result, what we got on the basis of a short information and using analytic tools, so we broke down the problems, then we got some solutions, then we got secondary problems out of them, and then it started to grow exponentially almost, and completely unclear what to do with it then. Because you cannot even put it on the screen. So we had to get some intermediate solutions everywhere where we have multiplication. The person should sort out this list, and then he will say, I will work with this idea, but not with that one. And then the options of the variance will be multiplied like that. But here it was like this. And one of the variants is sorted out. Of course, we would like to sort it out by the machine itself as well. So we got a lot of ideas of solutions, and one of the way outs of this situation is adjustment algorithm by sorting it out with some restrictions, limitations, and we can bring some list of requirements for every secondary task. Then we can implement some evaluation system and on and on. So we can understand where to move. And I guess this process will be on successfully. And then another idea which was gotten by us, dialogue should be built in such a manner. So problem solver puts it like that. So in blue color is what is made by LM and yellow color is by human. So it's a dialogue system. The system will give you a recommendation, and then problem solver will see the generation of this idea. And if the solution is found, then system is analyzing what is put by human here, and then it formulates some additional questions. More or less the same as it was with Anton's speech. So the system is able to formulate the question by itself, and then problem solver himself edifies it, like concludes it. So this is the last slide. So LLM can successfully use to assist in analysis. TRIZ works with it pretty well, but we have to use appropriate prompts and roadmaps. And to decrease this huge amount of information, we can implement some screening of unsuitable situation. So, colleagues, if you have any questions, Alexander, thank you very much. Thank you very much for your speech. So we have such a perceptions besides those conclusions that we have come down to a new level of brainstorm because of LLM. It's not us, but it's machine who came down to it. But however, we're users of those machines. And if we forget about trees and we find some roundabout ways to the heart of LLM, besides our trees tool, so it will work as brainstorm. So the question from Mikhail Semyonovich or comment to the slide number 7. I'm sorry, this is not a question, but it's more of a comment. Number 7. Thank you very much, by the way, for this message. It is always interesting to see and to know how this work is going on at our college. So, again, thank you very much for this report. So here I would like to share my experience. Of course, it goes without saying that we have made such research and what I pay attention to. In this left part, you are looking for some ideas and problem solving from AI. And after that, considering that there is some foundation, you are throwing it ahead further on, and you want those ideas and solutions to be developed by TRIZ tools. So in our experience, we haven't done it and we don't do it. So what AI does, according to our experience, he can figure out and dream up formulation of TRIZ tool in such a way that it will be adapted to its solution. So he's tricking somehow that his solution, which he gives, is relevant to TRIZ tools. He can give you some contradiction, some technique without changing principally the very solution. So we do it otherwise. We ban to him to find any, forbid to find any solution with our prompts which are put there. The first point there, first item. So in any case, don't look for solutions, but formulate this contradiction using those elements, and only after formulation by trees are there, we start to allow him to look for solutions. Otherwise, he will go down into the general conventional solutions, and so powerful solutions are not accessible to him. So, well, this is only my comment, my experience. Thank you very much, Mikhail Semyonov. This is very valuable information because every group works almost independently, and that's why experience exchange. It's a great time to share our experience. So we're not putting our questions so strictly as of now yet, but you can go both ways. In many cases, I would say, if the problem is pretty simple, is those things which are offered by LLM will give you direction, but not solution. Sometimes it's enough and sometimes trees problem doesn't require it. So yeah, we do it like that as well. So at first we check up if there are usual solutions on the first stage. If they are some
Да-да,
uh,
понятно. То есть здесь у нас
solutions, so
просто,
then you shouldn't
видимо,
do
на
anything
рисунке
else.
разные,
You're
а суть-то та же
completely
самая. То
right.
есть это
But
действительно
if we
такой
see
верхний
that
слой
trees tools are
общеизвестный,
necessary, so
осязаемый.
then
Если ничего не
we
нашли,
tell
вот
her
тогда
to
начинается ТРИЗ.
forget any other
Давайте
solutions which were there
продолжим. Да,
before.
есть вопрос от
Yeah,
Александра Бушуева.
these
Выходит, что
pictures are
она,
pretty different.
МЛМ,
So we
имеется в
cut
виду,
off a
должна
first
знать, что
layer,
такое
and if we
ресурсы. И мы
haven't
должны
found
сначала
anything,
ей
then
описать это
trees will be
понятие,
clicked in.
передать. Так
So
же, как
we
вы это
have the
делите
question
понятие
from
элементов.
Alexander Bushuev.
Совершенно верно. То есть мы сначала
So
ей
whether
должны, мы
MLM
часто это делали в промптах,
knows what does it
мы
mean
сначала ей
resources,
описываем,
or
что
you
такое
give
проблема,
this
что такое
task, this
ресурс,
Like you have
что
explanation to
это
it.
функция,
described
с
the concept
функциями,
of an
Completely
которые
right.
element.
появились. И только после этого просим
Yes, we have done
ее,
that quite
то есть совершит какую-то манипуляцию,
often.
да. То есть
With
ее нужно
prompts,
учить
we
такому
have
алфавиту, скажем
described
так,
what the problem is, what the
иначе она
resource is, what
начинает
the function
использовать
is.
все это
We spend a lot of
требование.
time to
Так
describe
что ее
functions, and then
подход
after
очень
that,
хорошо видно
we
было,
ask it
когда мы ее
to
просим, вот
perform
теперь
a
прием такой-то,
manipulation.
она
So,
все
and
равно
again,
продолжает лепить
we need
свое,
to teach it
оптимизируя ей наши
how
функции.
trees works.
Так
Otherwise,
что да, ее
it
надо,
starts using
ей надо рассказывать.
common
Можно это
notions.
сделать
It
в
was
промпте,
very
можно в системном
obvious
промпте, можно
in
даже доучить,
examples,
да,
so we
если есть
wanted
такая
it to use
возможность,
particular
то
examples, but
приходится
it
вот
kept
это
using
делать.
its own. So, and
Ну,
again,
я
you
так
need to train
предполагаю, у
it, you
вас
need to
должен
teach
со
it
временем
and tell it.
выработаться подход, как составлять
In this
алгоритм
system
составления
prompt,
промптов для
it is
TRIZ.
possible even to teach it further
Соответственно, какие
with that
рекомендации и
one.
так далее. И тому подобное.
Вот я образцы того, что у нас получилось, выложил. Это
Again,
прямо
so we
оригинальные промпты.
need to
Можете
think
посмотреть,
of
что ошибок
algorithms
нет.
on how to
Вправо.
Спасибо.
teach
И есть
LLM
вопрос
to
личной благодарности от Сергея
describe
Дмитриева.
and to
Сергей пишет,
derive
что есть
algorithms.
пример.
So there are a
Смотрим
number of
интересно,
samples
можно
that
ли
I am
исследовать
showing. These are
результаты
original
социально
prompts, and I see
признанные
that there is a mistake
нерешенные
here.
задачи.
In this one,
Это, наверное, у нас
also
скорее
Sergey
вопрос
Dmitriev
такой
would like to
для
Ну,
всех.
по-моему,
thank
похожий вопрос
for
уже
the
задавался.
Да.
examples for using
Что
AI.
делать,
Вы
если у нас клиент
Can we use
можете
пытается
AI to
получать
handle
деньги, да?
unsolved
Ну,
tasks?
конечно, можно.
можете
Конечно,
ответить в
можно.
комментариях.
Again, so
Да.
we have
Другое дело, тут вот
asked such a
фраза
question
официально
if
признанные
our
нерешенные
customer
задачи,
doesn't
это
want and doesn't know
что
what
имеется в виду, не
it
совсем
wants.
понятно. Там,
Well, we can do that. It is
прыжки на
acceptable
Луну попасть.
if you
Ну,
want to do
смотрите,
it.
есть задача, да,
Again,
и мы с
this
ней начинаем работать.
unsolved
Там решенная,
problem, this
нерешенная,
officially
официально,
recognized
неофициально.
unsolved problem.
У
There is
нас
a,
есть методика,
someone
которая
jumping to the
позволяет нам
moon or
работать
something
с
else. You need
нерешаемыми
to understand
задачами.
what this is.
Поэтому
If there is a
и
task,
здесь
whether
вот мы
it's solved or
показываем это
unsolved
все. И
unofficially or
если вы
unofficially,
просто
so we really
ей
need to
попробуете
look at
использовать в лоб,
this
да,
one.
то,
We have
скорее
the
всего,
method
ничего там новенького она
to
вам не выдаст.
work
А
with
вот если у нее
unsolvable
есть только
tasks.
методики, то
And
шансы
here we
будут
see
намного
how we
возрастают.
can use
Это
AI
как
for
минимум.
that. If you just
Ну
use
и еще один
AI
аспект от
outwardly,
Александра
it
Борцова
won't give
по
you
слову
some
есть
particularly good
исключение
results. But
использования
if you
системы
use a
поиска
method for that,
конкретных
the
людей при
chances for that
тематическом
are
подходе для
much
конкретной
higher that
ситуации.
it
Вот
will be
если таковые
successful. There is one more aspect highlighted by Alexander Bortsov.
то
In future, if we
добавлять
use the
математические модели с
system
примером
for finding
случая
inventions or
аналогичного.
mathematical models for particular situations, do we have such
Александр, если вам
a
это
model for
подробно
that? This is a question.
поясните вопрос,
Maybe we
потому что
could
я
add
чувствую, что я его
mathematical
не совсем
models and use with
понимаю.
this mathematical
Речь
model.
идет о
So it's a
разработке
scientific question.
математических моделей как таковых,
Alexander,
то, в принципе,
maybe after the
интеллекту-то все равно, с
session,
чем
I need
работать. Она
you to
работает с
clarify the
словами.
question because I
Если мы
feel that I don't
расскажем,
understand
что
the
такое
question, whether
математическая
you are
модель,
referring
как
to
она устроена, я
developing
думаю, она нам
mathematical
это
models.
сделает.
If
Другое
yes,
дело, что вот ее нужно
well,
опять-таки
AI,
специально
it
обучить.
doesn't matter what to work with, it works with words. If we
Или
tell
здесь
it
вопрос
what
про
a
что-то
mathematical
другое.
model
Есть
is and
концепция
how it works,
изобретения
maybe it
математических
could
моделей. Вот что это
give us an
такое?
answer. But
Это
again, we need to teach
новые...
the
Это
model
изобретение или
how to do it.
математические модели?
Александр, я предлагаю
Or
все-таки
maybe
это
your
продолжить
question
Да,
is
отдельно
about
в чате,
something
потому
different,
что
отдельно.
looking for
вы
particular
интересно
inventions
нам
or mathematical
читать.
models.
Давайте двигаться дальше. Благодарим вас за
Whether these
доклад.
are inventions or
Спасибо.
Меня
mathematical
благодарили.
models. Alexander, well, maybe you could
Итак,
move your
возвращаемся
discussion
теперь к